Enterprise smart contracts need more than correct code. In Besu networks, they must control who can act, create evidence for audits, evolve safely over time, and resist attacks. Those design choices are what turn blockchain logic into production-ready business infrastructure. You've already built the foundation: Besu basics, network architecture, contract deployment, and application integration. Now we shift from making contracts work to making them safe, maintainable, auditable, and ready for enterprise use. In an enterprise environment, a smart contract is not just a program running on-chain. It becomes part of a governed business system. Design starts with business rules, then adds permissioning, auditability, lifecycle controls, and integration with Besu nodes and applications. It also needs to account for the people around it: users, admins, auditors, and regulators. The key mindset is to treat contracts as long-lived assets that must be operated, reviewed, and trusted over time. Before a smart contract becomes code, translate the business process into a precise rule system. Name every actor and define what each one is allowed to do. Model the lifecycle as states, such as draft, submitted, approved, settled, or cancelled. Then define which transitions are valid and which must be blocked. Finally, capture approvals, exceptions, and assumptions. For example, only an approver should move an invoice from submitted to approved, and the contract should enforce that automatically. Role-based access control moves authorization away from one powerful owner and into explicit responsibilities. An admin may manage roles, an issuer may mint, an operator may update records, an auditor may only read events, and a pauser may stop activity during an incident. The central design principle is least privilege. Each account gets only the permissions it needs. That reduces mistakes, limits damage from compromised keys, and makes governance easier to audit. The owner pattern is attractive because it is simple. One trusted account can configure the contract and respond quickly. But as value, complexity, and teams grow, that simplicity becomes a liability. RBSC separates responsibilities so operators, approvers, and emergency responders only receive the permissions they need. For critical functions, add multisig or governance control. The goal is to avoid any single key having unchecked power over business-critical behavior. Besu enterprise networks apply permissioning in layers. Network permissioning decides which nodes, and often which accounts, may connect or submit transactions. But that only answers, can you reach the network? It does not answer, are you allowed to perform this business action? Smart contracts still need role-based checks, and application APIs should enforce the same rules. The safest design keeps these layers aligned, so sensitive operations are blocked consistently before and during execution. Events are the audit trail your contract deliberately publishes. Design them around business actions, not just variable changes. Invoice approved tells auditors far more than status updated. Include indexed identifiers such as actor, asset ID, transaction ID, or workflow ID, so applications, reporting systems, and monitors can search and reconcile quickly. At the same time, treat event logs as widely visible records. Never emit confidential data directly. Use references, hashes, or controlled off-chain records when privacy matters. State changes in enterprise workflows represent business decisions, not just variable updates. Model each lifecycle stage explicitly, then check whether the requested move is allowed and whether the caller has the required role. Only after those checks should the contract update state and emit an event. That event becomes the audit record: who acted, when, why, and which external reference applies. This helps prevent skipped steps, unauthorized approvals, and disputes later. A smart contract is rarely the end of the process. Its events become inputs for indexers, data warehouses, dashboards, and audit evidence. That means events need stable schemas and clear meanings, not ad hoc fields. Correlation IDs help connect a blockchain transaction to an invoice, customer case, or ERP record. But use them carefully, because identifiers can leak sensitive information. Store only what belongs on-chain, and let off-chain systems handle reporting, reconciliation, and controlled access. Upgradability is not something to add casually after launch. Because smart contract code is hard to change, the lifecycle choice must be made early. Immutable for maximum trust, upgradable for evolving workflows, or replaceable and versioned when migration is acceptable. Every flexibility option adds governance risk, so separate storage, business logic, and admin authority. Before production, define who can change what, under which approvals, and how users will be informed. There are three common ways to evolve contracts. Proxy gives maximum flexibility because users keep one address while logic changes behind it, but it requires strong governance and careful access control. A registry is looser. Applications look up the current contract address, so upgrades are explicit. Version deployment is simplest to reason about, but it may require data migration. In every approach, publish version metadata and define compatibility clearly before users depend on changes. Treat every contract upgrade as a controlled change, not a developer shortcut. Start with a request and impact review, then require security validation and formal approval through multi-sig or a governance contract. Before production, rehearse deployment and data migration in a test environment, including rollback paths if state conversion fails. After the upgrade, monitor behavior, publish version changes, and alert application teams early. Good governance makes upgrades auditable, reversible, and operationally safe. Enterprise contract security is not a final gate. It is a discipline across the whole lifecycle. Start by reducing known risks: reentrancy, weak permissions, unsafe external calls, and fragile admin keys. Then code defensively with current solidity patterns, input validation, checked return values, and minimal dependencies. Before production, combine automated tests, static analysis, peer review, and independent audit where the risk justifies it. The goal is not perfect code. It is controlled, observable, and recoverable risk. Enterprise smart contracts succeed when design choices are intentional. Enforce least privilege, make activity observable, manage upgrades through governance, and plan migrations before launch. These disciplines turn code into trusted business infrastructure. In Module 4, we'll broaden that foundation into network governance, compliance, security operations, and enterprise risk.